This is a new recording. We moved a few topics around and decided to teach like this property at a different place. So I have to record, and then the answer key for this new worksheet is uploaded, so that you can trust the one that's there. Okay. All right, we're gonna go ahead and get going. Unless you guys are like working on assignments and you feel like you already know these topics, I'm gonna ask that your involvement is with taking notes or working on the assignment as we talk, if that's okay. I feel like this can be a really, really easy assignment as long as you don't miss some of these early steps. Okay, so get engaged right now, and then I feel like you'll be great on this. Okay. All right, we're moving into our 6-2, which is inverse relationships between logs and exponents, exponential functions. If you guys haven't noticed that everything all along when we have been solving, I did not want to do that. That's going to bug me. Okay. Everything all along with solving throughout your years of math, you've noticed everything's had an inverse. And so as we move forward and need to be able to solve, you guys need to be able to solve exponential functions and logarithmic functions as its inverse. Everything we've had, addition has to have subtraction. Multiplication has to have division. Squaring and square rooting have to have each other, and so forth. So exponential functions, what makes it exponential for those of you who are here is that x is now up in the exponent. And we haven't dealt with anything like that yet, right? So think about if I times by something over and over and over again, that x has to be up in the exponent. And so it has to have an inverse. And its inverse is a logarithmic function. So we're going to be using logs today. Now, I'm not introducing logs quite yet. I suggest for your notes today, you guys develop almost like a table or an area that you have a list of properties of logs. I could have printed all the properties aligned, but I really want you guys to like have that writing aspect, that you get to write it down and you don't become so dependent on, oh, she gave me a list of properties, I'll eventually know it. I think it makes you guys know it if you're kind of like writing it down as we go. So, first property I want to teach you, property 1. We are going to first teach you guys how to manipulate exponents when they're in an exponent, and if they're given to you in a form that you can rewrite the bases to match each other, then you guys, your effort to clear that base to solve for x would clear both sides. So we just make ourselves more efficient, and we just realize, hey, if I were to try to solve for x, I would clear the base b. Well, guess what? My effort to do it to both sides would clear both of them. Why not just say x would have to equal y? This is kind of like a no-brainer, right? If this is true, don't you think this would have to be true? So that's your first property. If you manipulate the bases to match each other, your exponents would have to be equal. Cool? Okay, write that property down before I slide. I think it's a good idea to let's rewrite some exponents really quick so you have a good quick reference. And if you guys are pretty good at manipulating numbers, this will be a really easy portion of your homework. Okay, this is numbers 1 through 4 that were kind of, well, more than just 1 through 4, but this is kind of your numbers 1 through 4. Let's hurry and get some squares, cubes, and 4th degrees, and a couple maybe 5th and 6th degrees just in your head so we can use them, okay? So what I mean by this is when you guys see an equation and you notice both sides and you want to get the bases to match, let's make sure we know some of the squares. So like for instance, 1 is a square, 4 is a square, 9 is a square. Are you guys with me? What's the next square?
Would it be 16?
16 is a square. 25. Do you see what I'm doing here? 1 is just a 1 squared. So that one. And 1 can be rewritten in a couple different ways also. Okay? 1 can be rewritten as like any base raised to a 0 is technically 1. So you guys can rewrite 1 in a couple unique ways. Okay? Which we'll get to that. Isn't 4 technically a 2 squared if I wanted its base to be a 2? And 9 is a 3 squared. 16 is a 4 squared, but it's also going to be found in other areas too, which we'll look up over there in a minute. 25 is a 5 squared, right? So what's the next one? 36 can be broken down, right? What's the next square that can be broken down?
49.
49. Okay, what else? Let's do a few more.
64.
64 is a square that can be broken down to an 8 squared.
81.
64 can be broken down to a couple though, and we're going to notice that. What did you say?
81.
81 is another one. 100, right? And there's more, okay? I'm gonna just stop there, but hopefully you guys will start to recognize some of those. The more familiar, common, I'm gonna say common ones. All right, some of the cubes that we might see ourselves dealing with might be, so 1 is a cube. Oh, I did it the other way. I broke them down. I did the big numbers first. So 1 is a 1 cubed. What's a cube? Like, what's our 2 cube number? 8 can be broken down as a 2, right? And we're specifically giving you ones that can be broken down because it can't always work that way, and we know that, which we'll teach you how to solve that later. We're kind of solving the easy way and the ones that can be manipulated by hand, and then eventually we'll be giving you guys harder problems that can't be manipulated by hand that you would have to use a calculator on. And so we're going to start easy and then progressively get more difficult and add the rigor to it. All right, what's another cube? 27 is a cube. What's another cube? 64 is. So 64 can be written as a 4 cubed. It can also be written as a square. It can be also written as a 2 raised to something, and we'll get to that. Let's just stop at 5 cubed because we don't need to keep going. But what's that one?
125.
125, okay. Let's do a few fourths. So 1 is also a fourth. What's 2 to the 4th? 16. So 16 can be written as a 2, and 16 can be written as a squared. I'm going to stop at 3 to the 4th. What's 3 to the 4th? 81. Good. A couple other common ones we may see could be like a 2 raised to a 5th is what? 2 to the 4th was 16, right? So 32 can be broken down as a 2 as an exponent, right? 2 is the base. I don't know if there's any others I really am super stressed about. 3 to the 4th, I got 81. Oh, so 64 is also a 2 to something, and that's a 2 to the 6th, right? So those are some of the common ones you guys might have to break down. There's more, but we're going to get going. Everybody good with those basics? Okay, those are the common ones. Let's talk about how you guys will solve your first few questions. So these are kind of going to be your numbers 1 through 4. And the idea behind these is we specifically gave them to you so you can manipulate the bases, okay? So when I look at this, you guys have no known methods of solving these as of right now. We have not taught you how to solve when the x is up in the exponent. You would know what to do. You can't divide by 2 because dividing isn't the inverse of an exponent, correct? And you guys are going to learn how to do this with logs and later on. For now, let's do it by manipulating the bases. Let's do it by rewriting my bases on both sides to match, which we only gave you one side, but you can manipulate both sides. If we didn't give you just one side, that can be broken down. Let's use the property you guys just learned up above, okay? So can anybody think of a way I can manipulate this equation so that I can just use this property?
Give the other side x minus 1.
You can't just magically do that. You have to do something that's allowed. So you have to do things like balancing equations. So unless you keep that equation balanced, that's not allowed, right?
Solve.
But
So
can I?
you square the 2 to make it 4.
I can manipulate the 4. Like I can use this property by realizing, oh, these bases can be written as the same number. That 4 is manipulated down to a 2 squared. Have I changed that equation to be balanced? No. Right? Now what can I do?
Get rid of the 2's.
Yeah.
I essentially am not getting rid of them, but I am, right? If I were to clear them, it would clear both of them anyway. So it's true that my exponents would have to be equal. It's like I'm just like, sweet, my exponents are equal. Oh, I got my bases to match.
X equals 2.
I can take x, I meant to say y. X equals y. So I got my bases to match, x equals y. Okay, I'm going to clean this up because I'm going to be posting these notes. So, awesome. Let's solve this. Add a 1 to both sides, and what do we get?
X equals 3.
Good. When I check this, I would have plugged in a 3 up there and got 2 squared should equal 4. So when you check it, it should work. Now, could have we guessed what x was here? Because this one's easily guessed. Could have I realized that I needed a 2 squared there to get a 4, so I would have realized 3 as my answer. However, not everything's that straightforward. Like this isn't as straightforward, so don't get in a habit of just guessing and checking. Get in a habit of knowing how to solve this. Okay, let's use manipulation again. How can I manipulate this equation so that I can use this property?
5 is
5 squared. Or 5 cubed.
Good. 125 is also represented as a 5 cubed. I have now manipulated the bases to match. And now I get to say, well, shouldn't it be true that 3 equals 2x minus 1 then? Our ultimate goal is just solving for x. So if you guys can somehow get that x out of the exponent, that is your objective, is get that x out of the exponent so I can solve. Okay? Is that straightforward enough for us to be able to try 1 through 4 and handle it? Okay, let's solve this out just to get an answer in our notes. Those of you who are new to my class, on our group test day, if you remember, I kind of quickly told you a lot of information last time, but you guys get to use your notes for your group test day. So the more notes you have, the more you contribute to your partnership with your teammate to be able to do the test. So I suggest you get these in your notes so they're there to look at. Okay, does anybody need this slide before I shift gears to a new objective of the day? Okay, next objective is being able to recognize the inverse relationship. It's actually going to contribute this property. This is a new property. So everybody write down this property, okay, which I'll talk about in 1 second. These two are equivalent equations, and this is known as the definition of a log. A log can technically be equivalently represented as an exponent. And the reason why we have this definition of a log, don't worry about the around the world for a second, I'll help you with that conversion. And these conversions work both ways, okay? And they are equivalent. And the reason for them is this is going to be used in so many ways for the rest of this unit. This is going to be have you guys representing equivalent equations. It's going to be the way you guys solve equations when we can't manipulate the bases. It's used from here on out. This is the most important property of the entire unit that I want you guys to understand, okay? And it's called the definition of a log. And what happens is my base of my log. So your logs, you guys don't know this yet, but your logs have a base. Your calculator is a base 10. And so it doesn't work in any other base. So if this is a base 3, I have to be able to know how to manipulate that. Okay, so you can't just like type stuff straight forward into your calculator unless it's a base 10. Now, logs are functions. So log has to always have something in it, no matter what the base is. I can't just say, divide by log. Log of what? It'd like me to be saying square root. You're like, square root what? It's a function. Like square roots have to have something inside the square root or they're meaningless, right? They don't mean anything. Same with logs. So logs have a parentheses that you guys have to put something in a log. It's a function, okay? So with that being said, logs have a base, and if you want to convert it to an exponent, the base of the log will match the base of the exponent. And I do this a little around the world conversion thing, okay? Whatever the base of my log is, I get to raise it to whatever is all by itself. And then what was stuck in the log at one point, so this x is like stuck in the log, it gets to be pulled out and is by itself. We're going to use this method to solve later. To solve later, your variable will be inside the log, and so when I convert it, it's now freed. Now I can solve. And then when I want to solve an exponent and go backwards, I will be converting it back to a log. And notice this will be what is stuck. So whatever is stuck, we're trying to free. That's kind of essentially what this property is letting us do. If the y is stuck, I want to convert it to a log, so now it's free. If the x is stuck, I convert it to an exponent, so now it's free. Does that make sense? So you guys will use this property whenever you need to solve one or the other. Okay? We'll get used to it, I promise. So down here I have a whole bunch of, these are for your next few problems. Numbers, oh shoot, I've forgotten what numbers they are. 5 through 14. I don't want you guys to use a calculator, okay? So no calc, because I'm eventually going to teach you how to use a calculator. Will you guys please have your work shown on all these? I've left work off on my answer key to force you to try some on your own, but I know the answer keys are there. Try to force yourself to not depend on them. All right, let's do this. This is actually kind of fun. I know that you guys probably won't like it at first, but I promise it comes. You guys are either going to use inverses to solve these, or you can choose the definition of a log we just taught you to solve these. Okay, there's two approaches. Okay, if you're going to choose the inverses way, you will take what is in the log and manipulate it until the bases match each other. And if I am logging an exponent and the bases match, I essentially just undid it. And so my exponent is my answer. Like the value of this number would be 1 because I have a log base 2 of a 2 raised to whatever. And so since this essentially undoes each other, my exponent is my answer. So you will manipulate the inside of this till they match. So for instance, we already just did this a little bit up above when we had equations, and I want the value of this number. And you guys are going to eventually learn how to put that into your calculator. But for now, can you guys manipulate the 4 to be a base 2 but still be a 4? 2 squared, yeah. So 2 squared is 4. Well, since this log base 2 of 2 cancels, my answer is what? 2. Yeah, these undo each other, essentially. Okay, now let's do it using a definition of a log. Using a definition of a log, you're trying to rewrite it so you can convert it. So you have to first convert your log to an exponent. Then once it's an exponent, you get your bases to match like we just practiced. Okay? So over here, I would say, all right, log base 2 of 2 is equal to something. And I just named my something x. I don't know what x is right now. Then put it to an exponent now. Well, 2 raised to x should equal 2 if I do that conversion. 2 to the x is equal to a 2. Isn't this equivalent because we learned these forms are equivalent? Okay, well, manipulate these bases like we just did, and I already have that 2 raised to x should be equal 2 to the 1. Well, that means x should equal a 1. Isn't that what we got our answer to be? So you guys can either do the inverse way and manipulate the inside, but technically I'm taught by my college, like they want you to do this way. This is like the always works way. Because if your bases cannot be rewritten the same, you can't really do it this way, right? So that's why it's not always just proper to do it this way. Okay, I have a rule for you. Oh, let's do the next one actually. Let's practice it twice. Let's do a log base 2 of 4 should equal something. Let's convert that into an exponent now. Convert it to an exponent for me.
Would it be
2 to something should equal 4.
2 to 2.
Not right now though. So 2 to the x should equal 4. And obviously these are easy numbers, so you know x is 2. Or we do what we just did above, and we say 2 to the x should equal to 2 to the 4, 2 to the second, and so therefore x was 2. And then didn't we already realize that x was 2? This is more efficient, by the way. But this is like works all the time. Cool? Okay. Another rule coming at you. So if you guys want to go to your table that you set up a bunch of rules, here's your first one. Can you guys figure out a way, not your first one, your second one, third one actually technically. All right, can I rewrite this base to be a 5 to something that would have given me a 1? Or let's go over here and do the around the world. Log base 5 of 1 has to equal something. So 5 to what? Here's my x, would give me a 1.
0.
0. So this would be a 0, and now I realize, oh, the answer to this was a 0, or the answer to this, like, was x was equal to a 0. Let's see this property. A log, no matter what the base, if you are logging a 1, your answer will always be a 0. This is the rule, no matter what the base. And the reason for that is because no matter what the base raised to 0, that would have always given me a 1. Therefore, when you guys log a 1, let's just remember it's a 0. It'll save you time when you go to graph. Sound good? If you log a 1, the answer is a 0. So there's another rule to add to your table. All right, now on these last 3 examples, I'm going to pick. We're either going to pick the inverse way or the definition of a log way, and just kind of manipulate. Okay,
Do you prefer way on the worksheet?
nope. Nope, as long as the work's there, I don't care. So I think you guys just get in the habit of trying both so you have the skill set to do either. So what we're gonna, do you guys want me to do this way or that way? Should we manipulate and do the inverses way and leave it as a log?
Yeah.
Okay, let's leave it as a log on this one. So let's leave it as a log and let's try to rewrite that 4 to be a base 2 somehow. At the moment, it's a fraction, so I have to have it be not a fraction. So what could I do to it?
You can like somehow flip it by like
Yeah, if I flip it, what does that do to my 4?
that makes it like regular 4 or 1/4.
Yeah, what allows me to flip fractions
Uh,
as far as exponents
Is
go?
that 1/2 like?
You're close. You're on the right track. I could have kept this at 1/2. Okay, so you're wanting to do it a different way, which is
Oh.
fine. So I could make this a 2 squared. Is that what you're saying?
Sure.
It's okay if you're
I
not.
don't know.
Let's stick to this and we'll go back to that. If I make that a 4, 1/4 is not 4, so I gotta represent the exponent differently. If I reciprocate things, what does it do to exponents?
So you have to flip
Makes the exponent negative. Yes, she just remembered the exponent property. Is this 4 to the negative 1 the same as a 1/4? Yes, so make sure you are keeping them equivalent. And then we can technically make this 1/4 a 2 squared. So that 2 is raised to a negative 1. So isn't this technically a log base 2 of 2 to the negative 2?
Oh,
So what's my answer?
2.
Negative 2.
A lot of 2s.
A lot of 2s. Now, I thought Eric was saying this, so I'm going to just play on him and pretend maybe he really was. He was trying to realize that that's a 1/2 or a 2 squared or something, right? You could rewrite it. And now when I want to move that 2 to the top, I can make it a negative 2. Okay? Either way, we still get negative 2 as our answer. Now that's if we manipulate. I feel like this can get confusing to some people. So let's do the next one that way, because this makes more sense to some people. That's why I think it's important to know both ways, okay? So let's try E this way. We're gonna go over and do this way. So this one's kind of interesting. And the reason why I like this way is because our base is a 1/9, and you can't rewrite the base because you can't negate bases, exponents. So I like this one, converting it to an exponent so I can manipulate it how I want, okay? I'm gonna change colors to separate it. Okay, let's rewrite this. So this can be rewritten as a 1/9 raised to an x is 81. This is equivalent, right? But the cool part is I can manipulate both of them. Now, I can manipulate the 1/9 and I can manipulate the 81 and turn them both into 9. I can also just turn the 81 into a 1/9 somehow, and it really doesn't matter. So, what can I make that 1/9? A 9 to the what? A 9 to the negative 1, which I'm just going to put it on the x right now. And then how can I manipulate the 81 also?
Take the square.
9 squared. And I now have just created common bases. So now I can simply say negative x equals 2. Therefore, x was negative 2. I didn't intentionally make them both negatives. Sorry about that. Negative 2. But yeah, that's how it turned out. So do you see the benefits to being able to do the converting way? Because it gets tricky to manipulate sometimes. But again, over here, I could have said, oops, let me change that color. Over here, I really could have made this an 81 a 9 squared. Then I could have manipulated that and made it a 1/9 to the negative 2, and then it's solved. You know what I mean? So you can manipulate them the way you want. And then just for kicks and giggles, one last one. How can I rewrite a 64? We're so used to 64 being an 8 squared, but an 8 is not a 2. But it's a 2 to the 6th. So even though I know 64 is an 8 squared, I know it's a 4 cubed, I also know it's a 2 to the 6th. So you gotta be intentional with what this base is. Does that sound good to everybody? Do you think you could handle those problems fine in manipulating without a calculator? I'm going to quickly teach you how to use a calculator now, but I don't want you to do the ones that can be manipulated by hand. I don't want you to use a calculator if you can show the work. Cool? Awesome. Okay, let me hurry and do 2 more rules to add to your toolbox, okay? What if I have a 0 inside my log? Okay, let's try this. So let's put an x right here. 2 to the x equals 0 would be the conversion, correct? Is there any number that x can be that would ever give me a 0?
No.
No, because 2 to a negative makes it a fraction. We already learned that exponents last time have a domain of all reals. Notice how we had an asymptote at 0. Did we ever touch 0? Did we ever cross negatives or
No.
anything?
Does that mean it's undefined?
Yeah, it means it's undefined. So here's the rule. A log base b, no matter what the b is, if I'm trying to log a 0, it's always going to be an undefined answer. Okay, so, or I'm going to say just no solution. That little slash means no solution or empty set is what it means in mathematics. So, and we proved it using exponents. This is impossible. I cannot find anything that works. We proved it, right? Let's prove this one using exponents too. So if I want to do, hey, 2 to what would give me a -4? Is there anything that x could be that would allow me to have a -4? Don't tell me a negative exponent, because all that does is reciprocate things, right? So we have another empty set, because there was never any time this exponent turned out negative, right? The output never was a negative number. So this is another rule that you should put in your rule box or your toolbox there. No matter what my log is, if I'm trying to do a negative number of some sort, some negative number, it will also result in no solution. If I ever try to log a 0 or log a negative, you'll notice by proving it using exponents, you'll never have an answer that works there. A lot of rules. Hopefully you guys are doing okay. But as long as they're in your notebook, you can use them on the test. Okay, but what if I don't have something that the bases cannot be rewritten the same? So like, can I rewrite this 3 to be rewritten as a, I can't rewrite the 3 to be a 2 to anything, correct? It's impossible, so this can't be done by hand. This is actually our decimal answer. There's actually no nice whole number. So the ones that can be rewritten by hand, they're nice whole numbers. The ones that can't be, they're just decimals. So how does this go into my calculator? This is the change of base formula. Your calculator works in base 10 or base E. LNs are technically, which we actually are learning this on the next slide. I'm going to go down here. It's actually down here. LNs are technically a log base E, and they're on your calculator. They're in your calculator. Now, we don't do log base E. Instead, we say ln. This is known as the natural log. The natural log is the inverse of an exponent E that we just learned last time. We just learned E, Euler's number, and it's this number that's consistent with continuous growth. And so its base is an E. So I would convert this to an exponent by saying E raised to y is equal to x. These are equivalent. LNs and E's undo each other. Your calculator, log, is known as the common log, and it's a base 10. If you ever don't have a log written, your brain knows it's a base 10. But we don't always work in base 10, so you have to know how to put that into your calculator. So that's called a common log, and if I had something like this and wanted to convert it, I didn't get to clean up this slide like I did the others. I just hurried and did this lesson last year. So 10 raised to y is equal to x is its conversion, because they are inverses of each other, okay? Your calculator has a log base 10. I'll come back to this. Let me show you how to put this into your calculator. If I have a log base something of something, log of x with the regular base 10 one can be over log of b or ln of x over ln of b. It actually doesn't matter which one you use because they're both same bases. This is a base 10, this is a base e, who cares? So if you guys put this in your calculator, what would go on top? If we want to use the log button, it would be log of what over log of what? Is it the 2 on top or the 3 on top?
It would be
Or you could use ln of what over ln of what, okay?
3/2.
3 has to be on top, and then the log of 2 has to be on the bottom. So whatever your base is, it has to be in the bottom log on the change of base formula. So you guys could type both these in, and you're going to get the same exact decimal. Can anybody oh, sorry. People always forget that this is a function, so they usually put parentheses, and if you don't close the parentheses, you'll get the wrong answer. Cool? Okay.
Isn't it 1.58?
It
oh, wait,
is.
wait. 5 because of that 9.
You're okay, yeah. Right, that? 1.58-ish? If you didn't get 1.58, it could be that you didn't close your parenthesis on that top log, because it's a function, so you have to close that function before you do the next function. So don't forget to close that function, or press equals to just log of 3, and then say divide log of 2 if you're too lazy to close parentheses. Try it out, see if you guys are getting the same answers. It's about 1.58. Now, my reasoning that you guys will want to know this for tomorrow, what happened?
Yeah.
My reasoning that you will want to know this for tomorrow, so you guys are going to be learning how to graph logs, and if you guys plug in stuff, sorry, is there a question or are you just talking?
No, he was just.
Okay. If you guys want to be able to plug in stuff to your log and you pick stuff that's strategic that you can do by hand, you don't need to change a base formula, okay? But what if you want to plug in like 1, 2, or 3 that doesn't match that base? You will need to know how to put that into your calculator. And so you'd want to be able to find that number and then add a 7 to it. And so there's a reason we need to know, how to still do it with, with a decimal, okay? So we do have some problems that we're okay you use a calculator on your homework. So did anybody need the knowledge of like what a common log and what a natural log is? Or can I move on to doing your final examples? I can pause. So natural log, common logs, they're the ones that your calculator has buttons for. Cool. Let's do, and these have actually changed, so I gotta kind of change these numbers, and I didn't get to fix these slides like I had hoped. So your numbers, let me erase this, and let's say it's numbers 19 through 24. We'll have you guys go from exponents to logs. And then your guys' numbers 25 through 30. Oh, I wanted to erase that. Your numbers 25 through 30 ask you guys to go from logs to exponents. So let's do these together. This one is now number y equals 10 to, so 22. Let's do your guys' number 22 together, and then we'll do this next one together, okay? Simple conversions, and that's it. I like going log to exponent better because I can do the around the world. Exponent backwards to log is harder for me, so I usually start by writing my log out and then an equal sign, and then I kind of step back for a second. So you're fine. You won't interrupt me. You're okay. Thanks, Ty, for being respectful of that. If this is a base 10, what would I write here? Base what? 10. So that was raised to what? What goes alone? What should be freed when you guys convert exponents to logs?
They should free the exponent.
Good, that was stuck. And now when I convert it, it's unstuck. Makes sense? You know you converted it right if what was once stuck is now unstuck. So that means what goes inside the log. And we're not solving on these ones, we're just converting. Normally if we're solving, you only have one unknown. So this is equivalent to that. This is pulled out of the exponent, and I've now, let's just double check using the around the world. 10 was raised to x plus 1, and that was equal to y. So is this a proper conversion?
Mm-hmm.
Yeah. And so you just be done. You converted and you stop. So just conversions and stop. There's no solving. We're not getting an answer. It's just convert and stop. This one is now number, I think it's your 28. So everybody look at your number 28 and let's convert log back to an exponent. This one we're used to because we just did it the whole first few slides. So this one should be easy. How does this one convert?
But you do the base to base.
X over 3 to the other side.
So x over 3 is now going to be unstuck, and it is by itself. Is that what you're saying?
Yeah.
Good. It is by itself, so I can say 2 raised to y is equal to x plus 3. So what the base of the log is should have been the base of your exponent. So 2 raised to y is equal to x plus 3. Make sense? Okay. Now let's do one with e's and ln's, just so that you're not thrown off. So we're going to hurry and convert this one because it's an e. I believe it's on the exponent section, so I'm going to go back to the exponents because it's the harder direction in my opinion. This looks like it's your guys' number 23. Whoops. 23. All right. I know it's, oh, I should go back up here. Do I have to write this as a log base 10, or is it the same thing as saying log of y? It's the same thing.
Because
You don't have to write base 10. Yeah, it's like me saying x to the first degree. I don't have to do an x to the 1. X is just x, right?
I still do it.
So you can still do it. It is not wrong, and it's not, yeah, you're fine. Now, this one's confusing to me because I know it should be an ln in the long run, but it makes more sense to me to have a log base e. Okay? So log base e was raised to what? So what should be free by itself? X should be all by itself. And you can go either directions, by the way. I go this way for some reason, but we could have put x over there. It doesn't matter. E was raised to x, so what is stuck in the log now? If I convert this properly. E was raised to x, so that should be inside. The y over 3 should be stuck inside now, if I convert it properly. Now, we never ever write things as log base e, so this is technically what? ln of y over 3 is equal to x. And there's your conversion. Just convert, stop, that's your work. This is just a manipulation thing. You're not solving, okay? Now, let's go backwards. If I have an ln, I get to say e, pretend there's an e there, and I get to say e raised to x is equal to y over 3. And you guys can know your conversion. And that's it. So your homework has like those different objectives. Can you guys manipulate bases? Can you evaluate a log if it's manipulatable by hand? Can you still put stuff in a calculator? And then can you guys convert back and forth? So there's your kind of, 5 objectives. I'm going to be done.